Welcome back to Summarize Science. Today, we're asking a critical question for our autonomous future. How do we know the tests run on self-driving cars in simulations are actually meaningful for the real world? This is a well-known problem called the sim-to-real gap. A failure scenario found in a simulation might just be a glitch of the virtual world, not a real danger. Traditionally, the only way to be sure is to physically reconstruct the scenario on a test track, which is incredibly slow, expensive, and doesn't scale well. So, these researchers proposed a much more efficient approach. Since companies already have massive collections of real-world driving data, why not just search through it to find instances of these tricky scenarios? To do this, they created a system that uses a special programming language called Scenic to formally describe a scenario. Think of it like writing a very precise search query, like find all instances where a car changes lanes to avoid another car that is stopped ahead. Their algorithm then takes this scenario program and hunts for matching events within pre-labeled video data. This is far more complex than a simple keyword search. The algorithm has to be smart enough to confirm a match even if there are other, unrelated things happening in the scene, like a pedestrian on the sidewalk. To see if their method was effective, the researchers pitted their algorithm against two state-of-the-art vision language models, GPT-4o and Claude 3.5. These models were given videos and natural language descriptions of the scenarios and asked if they were present. The results were staggering. Their specialized algorithm was significantly more accurate, but more impressively, it was orders of magnitude faster. On average, their query took just 0.06 seconds, while GPT-4o took over 41 seconds to analyze the same clip. The researchers also tested how the system scales. They found that the query time increases linearly with the length of the video, which is very efficient. However, it does struggle and slow down exponentially as more interacting objects are added to a scenario, a limitation they acknowledge. So, let's quickly recap the important points. The researchers developed a highly accurate and extremely fast algorithm to find specific, complex events in large, real-world driving datasets. This method effectively bridges the dangerous gap between simulated tests and real-world performance. This is a huge step forward for verifying the safety of AI in self-driving cars. It allows developers to find real examples of potential failures and use that data to build more robust and trustworthy systems. Work like this is essential for building a future where autonomous vehicles can be safely integrated into our daily lives. That's all for today on Summarize Science. Thanks for watching.